Okay, so you should have Chapter 9 practice worksheet either downloaded or printed, and we're going to go through the first two questions and then we'll do the last two. So classifying matter practice. On the lecture, we just defined and gave a few examples, but we're going to go through a few real life examples of things you might see in your everyday life and then define them as a compound, an element, a homogeneous mixture, a heterogeneous mixture. So this is Gatorade. It's your normal bottle of Gatorade. It has an ingredient label. If you look on the ingredient label, there are all kinds of things in Gatorade, but it appears to be uniform throughout, meaning every drink you take has the same amount, roughly, of all of the ingredients. So that would make this a homogeneous mixture, because we know it's not pure because it's made up of more than one element or compound, but it appears to be uniform, which makes it homogeneous. The second example here is vinaigrette dressing. It has the oil and vinegar in it. We can see here that there are two different layers. There's this layer down here and then a layer on top. So this is normally your oil on top. So we know it's two separate layers. We know that if we shake up this container and we pour it over our salad, that it's going to, be a uniform looking distribution of salad dressing. However, because it separates and I could technically pour off this top layer from the bottom layer, it's called a heterogeneous mixture. We have a bottle of water here. We know that the label, it's just going to say water. We know that water is a compound. It's made up of more than one type of atom. So this is going to be a compound, and it's pure. This is a can of helium. It's what you use to fill up birthday balloons. It only contains helium inside, which makes this an example of an element. So now you're going to look around you and find an example in your everyday life of an element, compound, homogeneous, and heterogeneous mixtures. You're going to fill them in on your worksheet, and then you'll submit it. So let's practice naming. Now the first thing we're going to do is identify ionic or covalent, and then we're going to name it according to the rules. So magnesium fluoride. Magnesium is a group 2A metal. Fluoride is a group 7A nonmetal, so this is ionic. Carbon with oxygen, this is going to be two nonmetals, so covalent. Nitrogen and oxygen, both nonmetals, covalent. You're going to practice these three on your own and then submit them. So let's name according to the ionic rules. In the ionic rules, we get to name the first element just as it is off the periodic table. So this is magnesium. And then we get to name the anion and only change the ending to IDE. There are no prefixes in ionic compounds, okay? So no prefixes in ionic compounds. So carbon with oxygen and nitrogen and oxygen are both covalent, so we're going to name them according to covalent rules. We're going to start off naming carbon as it is. There's one of them. We have oxygen. There's two, so it's going to be dioxide because of that ending. Now in the second example, instead of having one nitrogen, now we have two. So we're going to call it dinitrogen. Remember, no changing the first element's name. And then now we're going to have four oxygens. So if you go back to your prefix table, this is tetra. But there's a really important rule that when we combine prefixes, we can combine I and O, but we do not combine A and O or O and O. Okay? When we have an A and O and an O and O next to each other, the O and O become a single O, like monoxide. It's not monooxide. The A and O are going to become only an O. So this is not going to be tetraoxide. It's going to be tetroxide. Okay. Now you're going to practice the 3 examples here and then submit this once you complete all of the problems and you're done with Chapter 9.